Hello, Flat Earth researchers, debaters and debunkers. With various globe Earth defenders making contradictions in their claims about curvature, I'd like to revisit some of the observations and experiments I did early on in my Flat Earth investigations. On the one hand, we have globe Earth defenders telling us we have to be very, very high above the Earth to see any signs of curvature, higher than the average passenger aircraft. And then the curvature is not in the surface, but an apparent dip at the horizon of just a few degrees, which you would hardly notice with the human eye and would need specific apparatus and devices such as theodolites in order to really test whether you can see any curvature or drop in the horizon at all. But on the other hand, we have globe Earth defenders doing low-level shots across water and landscapes and telling us that distant objects such as buildings and the bottoms of ships being cut off is also due to curvature. When I first heard about it, Flat Earth made complete sense, simply because of the fact that the horizon is always at the eye level of the observer. This is just something I've known all my life, and going up and down above a flat surface will either extend or shorten the apparent distance to the horizon. In fact, I vividly remember the first time I flew a long-distance flight and was disappointed not to see any curvature. The footage you're watching now is from various observations I made in my early months of Flat Earth investigations, just seeing what difference it made to get down to ground level and see what happens to the horizon. And as you can see, we have cars and motorbikes going off into the distance, appearing to dip down, and also going into the center of the field of view from the right or the left, following the laws of perspective. You can see the traffic cones in the middle of the road are cut off, and we have this band of convergence and mirroring just above the surface, and the surface itself coming up to about the halfway level of the camera's field of view. As the camera is raised, we can see that the road is flat and level, but of course it does have in it small deviations, small bumps. It's a rough, rugged surface, and that is what we find in nature anyway, a surface that will never be completely smooth. So this does truly represent the kind of conditions we see when we look out to sea or across a naturally flat landscape, which is never as smooth as an artificial surface. Again, we can see the mirroring on top of the surface. We can see these people walking across and their legs being cut off. You can see the trucks going off into the distance and appearing to sink down what we are led to believe is a curve when we look across an ocean or a distant landscape. And by rising up, everything comes back into view in the distance, and as we go back down again, it all gets more condensed and lost in this band of convergence. The band of convergence and mirroring that you see here is with the camera on the surface of a very flat children's playground, just looking maybe 20 meters across the playground and seeing this band of convergence. And you can see what happens as I step into the shot. There's lots of mirroring there. It's very difficult to tell where the actual surface is. I'm just showing the eye level in the camera, and you can see that this band of convergence comes up to eye level from the surface, and we can see it wavering in and out here. We've got this mirroring going on with the constant movement of air, temperature, changing density. So the bottom of the lighter here is obscured, or it is mirrored from almost or just beyond halfway down. There is this mirroring, so we never actually see the bottom. This is exactly the same thing we see when we see ships disappearing from the hull up, and in fact the sun going down and hitting the horizon and getting swallowed up in this band of convergence. And this is what we always see when we zoom in on a horizon. Yet we have globe Earth defenders with expensive equipment such as the P900, and they are seeing this band of convergence and mirroring. Yet they are totally ignoring it. We can see here that this box that I'm putting down completely disappears when it falls on the floor. Show that shot again. It just disappears beyond the band of convergence there. This is what happens to objects at sea, cars, people, boats, and the sun. You can't zoom in on it again. It's gone. It's beyond our vanishing line. And we can see here how the children's feet are cut off. Yet there is no curve, it's a flat surface. It's just an illusion of the light coming into our eyes. So no matter who you are or how familiar you are with navigating the Earth and how strong your conviction is that we are on a spinning ball Earth, when we scrutinize horizons, we can see that the slightest deviation in the surface, such as a ridge, a bump, a dip, or a wave, will create a blind spot beyond which we cannot see. And those blind spots become more and more condensed the lower we go, creating a band of convergence that cuts off significant amounts of the lower parts of distant objects, even though we know that any dips or deviations in front of us are certainly not any dramatic curvature. And while the mathematics for the distances we can see when we are looking across a globe may appear to work perfectly, we can see just by looking and allowing our eyes to see what we really see, that we can never ever really tell the distance to the horizon that we see, and we can never really tell how much of those distant objects will be cut off. But we can see that the convergence and mirroring that appears above the hard line of the surface and rises up to the eye level when we are looking straight ahead is what simply blocks anything that goes beyond it. And that includes something like the sun, which, due to perspective, will simply get closer and closer to the horizon as it gets farther and farther away. So in order to understand what we see, we have to consider how we see. This diagram of an eye shows us the light coming into the eye through convex lenses, creating a cone of light inside the eye, leading to the retina. And this tapering cone is how we see the landscapes and seascapes in front of us, with the surface and the sky converging at a vanishing line or our eye level. We can see this here with 3 beams of light going through a convex lens. The beam in the middle is going straight, but the beams on the top and the bottom are converging later on after going through the convex lens, exactly the same as happens in our eyes. So this point of convergence, where all the lines meet after going through the lens, is packed with information which becomes very condensed. So when we look out across a seascape or a landscape and we see the surface and the sky appearing to converge at eye level, this is where that's all happening inside the eye. We can illustrate this with a side-on view of a man looking directly ahead, with the red line representing his eye level, along which he will see his own personal horizon. His field of view, represented by the blue lines here, the actual field of view, obviously gets wider over distance. However, what our eyes see in front of us is actually a mirror image of the field of view, with these orange lines representing how we see the surface and the sky appearing to converge at the observer's eye level. So we can call this the perceived field of view, just as the cone of light is inside the human eye. This shot from one of the Star Wars movies of the Millennium Falcon jumping to light speed is a good example of that cone of perspective from the observer's point of view, with all the stars appearing to converge at the center of the observer's field of view in the direction he is heading. This image shows that a bit more clearly, and we instinctively know that those dots or lines of light that are converging in the center of the field of view are very far away compared to the ones that are higher or lower and therefore closer to us. And that's simply the way we see things, the law of perspective. So when we recognize that this really is the way we see things through our own 2 eyes, we can understand how perspective is all you need to know to understand how the sun, stars and moon are working above the flat earth, appearing to sink towards the horizon as they get farther away from us. So really there is no excuse for anyone with a pair of eyes to be ignoring this or refusing that it is a possibility, given our lack of understanding and knowledge about what really is going on in the skies above us. Thank you very much.